Great to meet you all. I'm Fawad Khaliq. If you guys use Amazon EKS and you don't like something in EKS, you can blame me for that. I was one of the early engineers there, helped launch the service, scaled it, and that's where we saw the insights where there were failures which were repeated and frequent across customers where they had no way to learn from each other. If there was one error, failure, disruption, another customer would see the same problem. They would just be reliving each other's pain over and over again. I've been with EKS for a while, and for more than 2 years, I've been with Check. I'm the founder and CTO. Today, I'll be talking about how to eliminate risks in your infrastructure as you make changes across any of the layers, either your clusters, your nodes, your add-ons, your applications, how to catch them before they happen, and how to make sure your upgrades are performed in a safe manner, and so you don't have to spend like months of research work. So let's get started. Let's start with the pain points. Right now, you get clusters from your cloud providers. Let's say Amazon EKS, GKE, AKS, or you may be running on-prem. You may have your homegrown distribution. You take those clusters, you bolt some add-ons on top of those clusters. These could be from open source. These could be from vendors or cloud providers. An add-on is something like gives you observability, certificate management, networking, ingress, service mesh, et cetera. A typical cluster is running from 20 to 40 add-ons. And on top of that, you have applications that you are getting deployed from your customers who are your internal application developer teams. In a typical enterprise, you may have more than 50 to 100 application teams, which are all your customers internally. And you offer these sort of a platform to your customers internally. The risk is anytime you make a change in any of these layers, you don't know what's going to break before it breaks. You don't know what kind of change is risky, what kind of incompatibilities exist within layers. So upgrades become risky and error-prone, and they can potentially break applications. What do you do? What do you do to ensure safety? You spend a lot of time studying what changes are being made. You would read release notes. You would reproduce, try to simulate things internally in dev and staging. And you would train engineers internally to become experts in every single vertical. Someone is an expert in networking. Someone is an expert in ingress and Istio and service mesh and other technologies. And even after them, their knowledge is limited to what they know, what experience they have had. The third pain point is the world is all about reactive response and reactive troubleshooting. Anytime something fails, you look at your favorite observability tool, like Datadog, Prometheus, Grafana. You see what failed. Then you look at logs to figure out what the root cause is. Once you find the root cause, you would run incident management to make sure that problem does not happen again, right? However, there's no way for you to catch and eliminate known risks which have materialized for someone else. That's where Check comes in. There's one more angle around upgrades, as if you are an AKS or EKS customer. If you're running an older version of EKS or AKS, cloud providers impose a 500% or 600% surcharge if you run an older version, which could be around $500,000 for every 100 clusters. So Check helps you around that as well. Let's look at the world today. This is something, we were at the keynote. This is sort of a similar slide here, where today organizations are reactively fighting repeated fires. If you have an error, failure, disruption, you would have, like an intermittent packet loss, for example, right? You would have the most experienced engineer go try to debug it. If they don't find the answer, they would look at GitHub issues, release notes. They would work with the community. They would also engage vendors and cloud providers. And eventually, they'll find the answer. And then another company repeats the exact same problem, or makes the exact same mistake, and then another, and then another. So these learnings are getting lost in silos. There's no way for them to avoid these known risks. And that's where Check comes in. With Check, you can remediate these risks before they cause disruptions. What we do is that we learn about these errors, failures, disruptions, which have happened already or got triggered somewhere else. We learn the root cause. We convert them into signatures, just like virus signatures. Think of it like a CVE for availability. We stream it to all of our customers. We scan and detect the infrastructure, and we give them workflows to safely mitigate and remediate these risks. So now you can learn from others' operational experiences and operational mistakes. You can prevent error, failure, disruptions, and you can save time and money. When you're performing the upgrades, which is one of the most time-consuming, error-prone, painful, and risky operations, especially on the lower layers of the infrastructure, which is your clusters and critical add-ons. There are hidden dependencies across layers, across components. It's a very labor-intensive work to identify what those dependencies are because they keep changing on every change that you make. It requires weeks and months of research work. And if you don't make that change, you are at the risk of downtime or non-compliance. If you're in a financial sector, it's not OK for you to run end-of-support or end-of-life versions. You have to keep moving. You may have security patches. So for those reasons, you have to keep moving to the newer versions to get new features, to make sure you have the security patches. Check makes your upgrade process a breeze. We help you get ahead of these hefty surcharges to fix these availability risks and to also stay compliant. How do we do it? Without check, your upgrade process today is that you have a fleet of clusters. Let's say you have 50 to 100 clusters you're running, or even more. You would have an upgrade cycle. Let's say you're upgrading from 125 to 126 or 126 to 127. You would read release notes. You would look at your infrastructure as code. You would figure out which of those release notes are relevant to you. You would come up with some sort of an upgrade plan internally, like a Google Doc or Word doc. Then you would look at what's changing in the layers on top. You would repeat the same process for each of the components, which means read release notes again, figure out what is relevant to you, what features and components you're using, and eventually you would have a huge upgrade plan, which is a document. You will give it to someone internally. You will say, go and simulate this upgrade internally on some sort of a dev staging environment. They will do a meticulous job on doing that. And after that, you will figure out who are the stakeholders. There are application teams who have a misconfigured pod disruption budget, or they are using a removed API, or there's a team which is using an envoy filter, which is changing right now in the newer version. You will chase all of those individuals. You will send notifications, get approvals, get the work done. And finally, you will perform the cluster upgrades and the upgrades of the critical add-ons. Check cuts down the research work and the pre-work by 8 times. We have a knowledge graph which generates this all for you. In terms of notification approvals, it's the same process that you have already. And then even in terms of the upgrade execution, we cut that down by 2x. So now we give you pre-flight checks, post-flight checks, upgrade steps. So end-to-end, your process becomes 3x faster and significantly safer. How do we do it? Check offers you Kubernetes availability platform, which helps you identify what breaks before it breaks. We help you speed up and de-risk upgrades, saving you time and money. It's delivered as SaaS. It works with any Kubernetes cluster, as long as you are upstream API compliant. We work with multi-cloud, multi-prem, AWS, GCP, Azure. All of those are supported. And we cover hundreds of add-ons from open source vendors and cloud providers. If you don't cover an add-on, you can request it. It'll be added within 48 hours. That's our SLA to you. And we integrate with your existing workflows. We offer 3 product modules. I'll talk about each of them in the following slides. The first one is Risk Ledger. The second is Artifact Register. And the third is Upgrade Copilot. And our technology is called Collective Learning that powers all of these 3. And I'll walk you through that as well. Let's look at the Risk Ledger. The Risk Ledger helps you eliminate risks before they cause incidents. Where, let's say you're running a defect. There's a memory leak which is present in one of the components. Let's say you're running external DNS. And if you're using Route 53 records, and there's a memory leak in external DNS, we will tell you there's a memory leak, and you can go catch it. If there's an intermittent packet loss, so you're using Nginx ingress controller, and that happens 6 times a month because you are on a certain configuration, we call them trigger conditions, we will tell you it's a known risk. You should fix it before it causes outage on your side, especially if you are sensitive on the ingress side. These are all different categories of risks that we report in the Risk Ledger. You could be running a deprecated API or deprecated registry or a removed feature. There could be something incompatible. You may have misconfigured something. You may have a defect. So with Check, you can prioritize your top business critical risks with clear and actionable insights and continuously harden your availability and safety story. And you can learn from others and avoid repeating known mistakes. The second module is Artifact Register, where we catalog all the containers, all the clusters, add-ons. So right now, you have some sort of a spreadsheet or a wiki page or a conference page where you have all the add-ons you're running, what versions you're running, and then someone has to go and manually maintain its end of life. Is it incompatible? Since we are connected to your systems already, we'll tell you, what is end of life, what is incompatible across your entire fleet. Could be across cloud environments, across regions, across multiple accounts, all in one place. So you never have to use spreadsheets again. The third and the final module is Upgrade Copilot. With Upgrade Copilot, we help you de-risk and speed up upgrades. And we cut months of research work. And we help you upgrade safely. The way we deliver Upgrade Copilot is that there are two key abstractions here. What you see here is one of the abstractions is called stages, and every stage has one or more steps. So you see over there, we perform the pre-work for you, which in this case, we will contextualize the release notes. We'll tell you what is changing, what is your current version, what's the recommended versions, what's your current config, what's the recommended config. We give you pre-flight checks, we give you post-flight checks, and we give you steps to perform the upgrade. Check really works as a co-pilot, where someone would have to do all this research work. They'll have to compile this upgrade plan. Check will generate this upgrade plan where you can go add your own custom steps and then execute the upgrade. You can delegate to someone who was not able to do it before, because typically right now it requires judgment from the most experienced engineer on the team. Right now you can generate an upgrade plan and get it approved, delegate to someone, and they can go and execute it, and Check will become that system of record, will also become your co-pilot. So now you get better conformity, you get fewer incidents, you have lower operational loads, and improved team productivity. And you can plan ahead, 3 months ahead typically when you plan these mission-critical upgrades. Now you must be wondering, how does this all work? The technology that powers all three product modules is called collective learning. There are two key components in collective learning. First is RSigDB. It's a short form for Availability Risk Signature Database. Think of it like a CVE for availability. The second is the knowledge graph. In RSigDB, we store the codified representation of all these errors, failures, disruptions, incidents, outages that have happened for someone else. The second is knowledge graph, where in a graph data structure, we store the relationships across all of these entities, an add-on, its versions, its release notes, its upgrade considerations, known defects. So when you move from one version to the other, we can traverse the graph. We can tell you what the safe path is, what the golden path is. We can tell you what is incompatible, so you don't have to go through that experience. You don't have to go do all that work, which is sifting through all the raw text of release notes. Now, you must be wondering, where do we source this information? There are three sources. The first one is we mine the internet, which is GitHub issues, release notes, official documentation, pull requests. You are looking at this information already. Your engineers are reading official documentation. What is the compatible version? What is end of life? I am running into this issue right now. Someone reported that already. That's the first source. The second is we partner with add-on vendors, because they have their own support load. They have their own users. And there are some trailblazers, and there are someone who are following them. So if someone has seen a problem, why would you go repeat the same mistake again? We become a trusted broker here. The third is our users voluntarily report these risks back to us. We do not automatically learn. They can report them in sort of a report format. All of these three feed into, in sort of a raw feed, into an internal mechanism where we have Check research team, which is responsible for making sure there are no false positives. They curate these risks. They have to validate them. They have to reproduce them if they have to. And then they convert them to codified signatures and publish them to the RSigDB. And we have tools like watchers, retrievers, summarizers to scale this process. On the left side, we connect with your Kubernetes clusters by giving you a lightweight agent, like a cron job that collects the right metadata. We also connect with your cloud substrate, which you get metadata from across layers. And we send that metadata to our service, where we run these engines that power all three product modules. And then we offer you integrations for tracking and reporting purposes that integrates Check into your existing tools. And we give you a dashboard via the API, where you get to see risk ledger, where you can see what risks are there, artifact register to see the inventory of what you're running, and the upgrade copilot to perform upgrades in a safe and timely manner. With that, I'm going to take a pause here and open the floor for any questions. I did not get the information from this. This is a first-hand insight when we were working at Amazon EKS. our customers would come to us and they would say, I'm making this change and something broke and I don't know why it breaks, it's your fault. So being customer obsessed, we would go work with them, we would spend time with them. We will really find the solution or the fix for them. And once we publish the solution, we'll also come up with some sort of a knowledge base article, like a KBA. We'll give to the support team, which means if someone else comes in, they will have access to it. So we don't have to do the duplicate effort. In most cases, these problems were in the layers owned by the clusters, because there's shared responsibility model, right? Your clusters are managed by EKS, and they do an amazing job. And then the layers on top, you own them, which means you take components from open source, you take components from vendors and cloud providers, and you guys are experts. You run them on these clusters. Now, it's your responsibility to make sure they all work together. It's your responsibility to tune them in a way that they serve your business case or internal applications. So that's where it was very painful. That story of me getting paged is actually true. I've actually got paged multiple times. Our biggest source is the first one, where we mine the internet. This is actually the smallest source over there. This is where anyone who's running, let's say, a Jupyter notebook, and they say, on this version of AKS, it doesn't work. They were the trailblazers. They found it, and they said, I feel like contributing back. They contributed back. So we get to learn about it. Now it's published. It's all anonymized. Some users also want to maintain an internal version of this for their own company. So if you are part of a large enterprise, and you say, I don't want to share these learnings with anyone else because they're all very specific to my company, you can do that as well, which means you have a private instance of this. And over there, if you have a culture of sharing learnings within the company, this works very well, where you can say, I have these 40 teams right now, and if one team is making a mistake, I don't want other 39 teams to go through the same pain again, which means now you can cache those, you can track their life cycle, and you can chase those people to make sure to fix them before they cause any outages. So this is the biggest source. In terms of add-ons, we cover more than 200 add-ons today. And if you don't cover an add-on, you can request it. We'll add it in 48 hours. Great question. Chaos engineering creates more work for you. You have to go and allocate the time, hire people, and they have to do chaos engineering. They will find all sorts of things over there. They will even find things that you may never have to, you may never run in terms of production. That's one. The other problem is, let's say they find all these problems. Where do you find the fixes? You have to go back to the community, who's also understaffed, and you'll go to the author and say, by the way, we found this very special case under these conditions. There's a race condition that happens. And they'll say, can you reproduce it? And you're like, yeah, this is there, but no one else is seeing it. They may or may not fix it. So you are relying on them to go cache those. So it's a great tool for finding the bounds of a system and what can fail. But in this case, the known failures, the known risks, someone has run into it already. Let's say you're running Carpenter, and in a certain condition, it can spin up a wrong instance for you. And it can lead to a it becomes a big problem. It seems like you have run into such an issue. So that's a known issue. Why would you go repeat the same mistake again? Or you have an intermittent packet loss, someone has run into it. So that's the big difference. We're not creating more work for you. We're actually reducing work for you. We're just telling you what's known out there. It's not going to catch 100% of the issues. That's the reality, right? So our guidance is, coming from AWS, we make sure that you guys wait. The definition of bake time, wait for others to try it out, and that's the beauty of open source. You get enough users to go try it out and tell you these things work, these things don't work, and then you move, especially if you're running mission-critical workloads.
Do you foresee putting a large language model in front of your knowledge base?
Great question, and I've been asked this question before as well. The way this technology is there today, right now, based on the current implementation and the current capabilities, not 5 years from now, I give a very simple response to this. When you talk to machines, they give you two types of responses. Either they give you a best answer, or they give you the exact answer. You're in New York, and you're searching what's the best pizza shop in New York. Google will tell you what's the best pizza shop in New York. That's the best answer, and it works for you. Because you go there, chances are it's going to be really good because there are all these reviews over there. When you're making mission-critical decisions, you cannot rely on a best answer. you have to have an exact answer. You cannot get an answer like, yeah, I tried out, it may work, but something may work, something may fail. You need an exact answer. Yes, do this. You're upgrading your CSI driver. If you just change the sequence, you may lose all your data. Not worth it. The systems are not there. So that's why the knowledge graph is supposed to give you the exact answer today. Eventually, these capabilities of the LLMs will be at a point where you can go and make sure there's no hallucination and can give you all of those things. Right now, we're in the business of exact answers. We're in the business of availability. We are actually not OK giving you something which is probabilistic, and you may make that decision and come back to us and say, you told us something, it would work, it didn't work, we have a problem. That's exactly the case where you have your internal tooling. Right now, the way we have abstracted it, the definition of add-on is something which is in the open source from a vendor cloud provider. It could have one GitHub star. We will still consider that an add-on. If you have something in-house, which is a controller, we call that an application. You can have different labels for those. If you have risks that you have internally identified and you want to share between teams, that's where you get a private instance of that RSecDB, where you can maintain. You don't share with any other company. This is all your own instances. And you can get the same capability of the engine. It will report you, and you can track how much of those are fixed. You can define the severity and the criticality of those things. If something is critical, of course, you got to fix it immediately. If something is medium severity, teams will come and ask for extensions. So all of those workflows are built in. Okay. Yes. 5 minutes. We have 5 more minutes for questions. Yes, you had a question.
So you mentioned that there are agents or there's an agent that's deployed into the cluster. Is that deployed onto the control plane nodes, or is it deployed across all nodes?
Right now, it's a very lightweight cron job that runs on one of the nodes. We will eventually expand into other areas as well. That only talks to API server. It's read-only permissions. You control what exactly it looks like. We give you filter rules to redact any part of the tree. And yeah, it's. It talks to the SaaS, but if you have very specific networking requirements, those are, of course, we can handle those as well. Yeah. Yes.
You have mentioned that you provide workflows given that you identify the risks or potential failures. Can you talk through this a little bit around those workflows and the implementation path?
Yeah, great question. So let's say you find a risk. You have to go fix that risk. So think of a risk like a workflow, which means now you have n number of affected resources. It could be 1, it could be 5, could be 10. Those affected resources could be owned by different teams, right? Now you assign those risks to, we call them latent availability risk, or risk in this case. You assign to the right owner. You can track their progress, which means someone say, this is by design. I know about this risk. This is by design, so I'm going to mark it. Or this is my dev test cluster. I'm going to ignore it. Or they say, I recognize this risk, but I have a workaround right now for 3 months, which means give me an extension for 3 months. All of those workflows are built in, which means anything that you see here, which is reported to you, it's a workflow where you can assign action items, you can create a ticket, you can assign to the right people, you can change the severity. You will get all of those controls, because at the end of the day, you may have some additional knowledge, which we may not have, and then in certain cases, you may want to override what we give you. So that's what I mean by workflow. Does that answer your question?
It did, but I was hoping that you could provide a little bit more details on specific, for example, the risk is identified, and the step of the workflow, how to fix that risk.
Good, perfect. In terms of the workflow, we also tell you what are the affected resources. We give you steps to mitigate and steps to remediate. So in this case, whatever the fix is, you'll get a remediation steps that you can perform. If the remediation, which means the fix is not available, I was showing to someone right now, there's a node lease leakage right now up to like version less than version 129, where with the activity of nodes, the leases don't get garbage collected. So over time, they get built up, and your XCD can go into read-only mode, which means eventually your deployments will start failing. It's a ticking time bomb. It will happen over time. So the fix is not there, but the remediation is there right now, which means you can go and write a job which can clean it up every 24 hours, or 1 week or 1 month, based on how much activity is there. We will give you both of those in terms of workflows, which in this case, you can mitigate it or you can remediate it. Yes.
Is there any way to figure out the price of implementing the check in an existing workflow? Or is it just if it's public information, right?
How much does it cost?
To implementing an existing workflow.
Talk to us after.
Okay.
I think we have 2 more minutes. Any other questions? If not, we have a booth upstairs. There's going to be a happy hour as well. Feel free to drop by, ask us questions. We're happy to dive deep, and also more than happy to set up a follow-up.
You guys thinking about maybe open sourcing some of that? Or
We should talk. Awesome. Great. Thank you, folks.